My name's James. I work with exploration geologists, and I'm going to show you how we use this device, which is called a rocket launcher, to measure structural features in diamond drilling core. So what this does is it essentially takes a cylinder of diamond drilling core like this and orientates it in the correct geometric orientation that it was actually drilled in. So it will place it in the correct azimuth or strike and the correct dip for how it was placed in the original rock body before it was extracted by the drilling. Now this is very useful because it means we can actually directly measure geological structures with our compass clinometer in the correct orientation, in the original geological orientation. So one thing to note before we go any further is, of course, if we're going to use our compass clinometer rather than metal core trays and things like that, the rocket launcher itself and the workspace that we're using should be non-ferrous. So it shouldn't have an effect on the magnetic field and cause our compass to deviate. So you can see here we're on a nice wooden bench and we've got our nice fairly simple rocket launcher set up here. Which is what we're going to use to orientate the core. Okay. All right. So the next stage, once we've got all our equipment ready to go, is that we need to orientate the rocket launcher to the correct azimuth for the drill hole. So, for example, using my digital compass on my iPhone, we can align this long part of the rocket launcher to the correct bearing that the drilling happened on. So here we can see this drill hole was actually drilled at 30 degrees northeast, and so I've already aligned it to that compass bearing. So now the drill hole, when I place it in the holster, will dip towards the northeast on the correct bearing. So that's a very important part of the procedure. Next, in order that our data is going to be accurate, we need to actually level the base of this rocket launcher. So at the moment it is about a degree off, which is going to cause an error in our data. So using various things, little bits of rock or whatever, anything simple, I'm using a pen in this particular instance, you can prop up the underside of the rocket launcher until, hopefully, you get it level. This can sometimes be a little bit fiddly, but there we see we're now level. Okay, so our rocket launcher is now aligned along the correct azimuth. It is nice and level. So the one next thing to do is to align the actual holster so that it is dipping at the correct angle. So drill core is quite typically drilled at around 60 degrees. This one was drilled more like 45 degrees. So I'm going to use my clinometer on my phone to align that accurately. So using this clinometer here, we can see that that's currently around 55 degrees. So if we just adjust the rocket launcher slightly to 45 degrees, and then we just tighten it up so that the core doesn't move around. Okay, so once that's all done, that's all in the correct orientation. That is now representative of the geometry that this drill core was drilled in. Now we can take a piece of diamond core, one with a nice obvious structure in it. So this is our length of diamond core that we're going to measure some structures in. This is a vein which is forming this sort of oblate cylinder around, or oblate ring around the diamond core, and of course most diamond core should have drawn on it, when it comes out of the casing, an orientation line. This marks the bottom of the hole, so the bottom of the hole like that, and it should have arrows that point down towards the bottom of the hole. So this will help you orientate it in the rocket launcher holster. So if we take our diamond core, very carefully just making sure you place the orientation line in the center at the base. And now this diamond core is in the same orientation as it would have been when it was still in the rock package prior to being drilled. So now we can really quite simply take our compass. I'm going to use my iPhone compass clinometer rather than a traditional compass clinometer, and we can directly measure structures in their original orientation. So we can see that this particular structure would have dipped 85 degrees towards 235 degrees, and that is a pretty accurate dip strike off that geological structure taken from diamond drill core.